on to lesson 2 in scientific notation. If you remember, in lesson 1, we looked at these and we decided whether or not they were in proper scientific notation or not. And we had a few that weren't. Well, we're going to look at that again today. So if we look at these, try to pull them out of the glare a little bit. Is this one in scientific notation? Get a little closer in. All right, is number 1 in scientific notation? No, because this number right here, the coefficient, has to be between 1 and 10. So, nope, that one's not. How about this one? Hey, look at that. Yes, it is. It is in proper scientific notation as far as the coefficient goes, because it's between 1 and 10. Then we have times 10, and we have our exponent and our 10. This one is looking good. This one is, yes, it is in proper scientific notation. How about this one? Does it matter that that's negative? No, because we always are going to go with the absolute value. So you can ignore the negative for right now. But is this number between 1 and 10? And the answer is no. How about number 4? How about you guys do 4 and 5? Pause the video, do 4 and 5, and come back. This one, remember, we're going to ignore that for right now. Is this between 1 and 10? Because we're going to do the absolute value. Remember, absolute value, it looks like this. So it would be negative 61 and 43/100. Absolute value looks like those railroad tracks. All that means is you're going to ignore this negative, and the absolute value is how far it is from 0. Well, if we are on a number line like this, and 0's in the middle, and we go down to negative 61 and 43/100, how far is it from here? Well, it's 61 and 43/100 from here. So it's always going to be positive. So, is 61 between 1 and 10? No. So that one's out. And how about this last one? Is this number 4/100 between 1 and 10? And the answer, of course, is no. So in today's lesson, we're going to talk about fixing them if they're not in proper scientific notation. How are you going to fix it? Well, I'm going to show you. So if we look at this one, this is number 1. How can we fix this? The decimal point needs to be moved over 1, doesn't it? It has to be moved over to there. It has to jump to there. So it needs to be moved over 1 space so that the coefficient is between, what are coefficients supposed to be between? 1 and 10. If we do that, it's going to make that coefficient 1 place value, remember each of these is a place value, 1 place value smaller. How do I know it got smaller? Because it was 43 and now it's 4. It was 43 and 2/10. It's now 4 and 32/100. This number is obviously smaller than this number, right? It got smaller. So we want to keep everything balanced. So when we make this smaller, so we're going to keep it the same number. If you make the coefficient smaller, which is what we did, you're going to make the exponent larger. So it keeps it balanced. If you make it 2 place values smaller, you would need to make the exponent 2 larger. If you made it 10 place values smaller, you'd have to make it 10. You made the exponent 10 larger. So in this case, we only moved it 1. So it's 4.32 times 10 to the, we made this 1 smaller. We need to make this 1 larger. Ta-da! Look, it's in scientific notation. This is between 1 and 10 times 10, exponent on the 4. Let's look at this one. This is similar to number 3, except for I took the negative off, so we don't have to worry about that right now. So what are we going to do with this one? Well, here the decimal point needs to be moved over, again, one space so that the coefficient is between 1 and 10. We need to move this decimal point from here over to here. Okay, it needs to end up there, yes? We want it to end up looking like that because 8.5 is between 1 and 10. This will make the coefficient one place value larger, right? It was 85 hundredths, and now it's going to be 8.5. It got larger. It went from here to here. This one got smaller. This one's going to get larger. I'm smearing the ink around, I think. All right, to keep the number the same, keep it balanced, if you make the coefficient larger, which is what we did, you need to make the exponent smaller. So, times 10 is always times 10. But what are we going to do with this exponent? We made this 1 larger. This has to become 1 smaller. If you'd have to make it 2 place values larger, then the exponent would become 2 smaller. If you made it 10 place values larger, it would become 10 place values smaller. The number of place values that the coefficient moves is the number the exponent has to change. If moving a place value makes the coefficient larger, the coefficient gets larger, then the exponent has to get smaller to keep it balanced. If moving the place value makes the coefficient smaller, then the exponent would get larger. So we need to go up and we need to fix numbers 4 and 5. So number 4 originally looks like this. We are going to, let me zoom in on this. We are going to take, I'm going to try a focus and see if that helps any. Hopefully that did. And 61 is not between 1 and 10. We're going to keep that negative sign there. It needs to move over 1 to 6.143. Always times 10, don't forget that. And what happens to this? Well, this was 61, and now it's 6. It got smaller. That means this is going to get bigger. What's bigger than negative 7? One place bigger than negative 7 would be negative 6. And there you have it. Always this little negative this negative that's going on to your coefficient, just kind of bring him along for the ride. All right? Let's try number 5. Number 5 is 0.04 or 4 hundredths times 10 to the negative 5. On this one, the decimal point has to move. If it moves to right there, is 0.4 between 1 and 10? No, it has to move 2 spaces, so it's 4. Always times 10. And then you're going to go, 0.04 to 4. It got 2 place values bigger. This has to get 2 place values smaller. What is 2 smaller than negative 5? 2 smaller than negative 5 would be negative 7. Boy, I hope all of this is in on the camera. I can't totally see it, so hopefully it works. All right, let's do some practice in proper scientific notation. You need to try to write each of these, so stop the video, write each of numbers 1 through 5 here in proper scientific notation, and then come back and check and see if you did it right. Okay, on this one, we're going to make it 1 smaller. So it became 1 smaller, so it's between 1 and 10, which means this needs to become 1 bigger. On number, let me circle that so you can see it. On number 2, this, hey, that's already between 1 and 10. Times 10, that doesn't need to change at all, it's perfect. Let's see if this is proper scientific notation. Nope, not between 1 and 10. If I move it over 1, is it between 1 and 10? Nope. If I move it over another 1, oh, now it is. 6.32 is between 1 and 10. Times 10. This got 1, 2 spaces. Did it get bigger or smaller? It got bigger, which means this guy's got to get 2 smaller, or it would be 1. I'm going to go ahead and put the 1 there for right now. Even though we normally don't show an exponent of 1, I'm going to go ahead and put it there for now. All right, let's go to the next one. That's not right. We're just going to put the negative down so it's there, and we can ignore it now that it's there. Where's the decimal point here? It's over here. We need it to make, obviously 673 isn't between 1 and 10. We need to make it jump 2 this way, so we get 6.73. It got 2 place values smaller. It was 673, now it's 6.73. So it got 2 smaller, which means this has to get 2 bigger. 2 bigger than -5, -3. Go back and circle that one too. And finally, this is going to get 1 what? From 44 to 4 got smaller, which means this needs to get 1 bigger. 1 bigger than -2 is -1. Okay, your job is the rest of this. So on the back or on the second page here, you're going to take and put each of those in proper scientific notation. You're going to take and put each of the, oops, that's not true. On these ones, you just have to say yes or no. Are they in proper scientific notation or not? Then on 6 through 17, those ones you have to put in proper scientific notation. Numbers 18 through 29. This is a review of lesson 1. If you are confused, go back to lesson 1 and go back to this paper right here to help you in your converting either from standard to scientific or from scientific to standard. Okay? Get that all done. If you have questions, let me know.